Good morning, good evening, good afternoon, and welcome to the third BitcoinCash developers meeting of 2020. I'd like to take this opportunity to introduce the panelists today. On my top left, Antony Zegers, if you could introduce yourself, please.
I'm Antony Zegers. I work on Bitcoin ABC. That's about it.
Jason B. Cox.
Hi, I'm Jason Cox. I'm a software engineer contributing to Bitcoin ABC.
Thank you, Jason. Chris Troutner.
Hey, I'm Chris Troutner, founder of the Permissionless Software Foundation, and I'm working on fullstack.cash blockchain as a service.
Great, thank you, Chris. Amaury Séchet.
I'm Amaury Séchet, founder of Bitcoin ABC.
Thank you. Josh Green.
Hi, I'm Josh Green, lead developer of Bitcoin Verde.
Excellent, thank you. And Jason Dreyzehner.
I'm Jason Dreyzehner. I work on BitAuth.com.
Okay, thank you. Andrea Suisani.
Hello, Andrea here, Bitcoin Unlimited developer.
Thank you, Andrea. And Chris Pacia, Pacia, no, Pacia, got that wrong, sorry.
Either way, whatever. Yeah, I'm Chris from BCHD.
Excellent, thank you. Glad to have you all here. It's been a busy couple of months and lots going on. So I'd like to move right into the subjects that we're going to tackle today in preparation for the update on May the 15th. And we'll start with any Avalanche and QUIC updates, QUIC updates, what work is being done. Amaury, could you take us through where you are with that?
Yeah, well, it's moving forward. I don't know. I don't have reached any specific milestone that is worthy of a big announcement, I'd say. So it's just, yeah, it's just chugging along. It's happening.
Okay. And people are able to follow the work that's going on in a variety of places?
Well, the same as usual. I mean, review.bitcoinabc.org for anything related to Bitcoin ABC. For QUIC, we plan to use the library called MVST.
Okay.
And so they have a public repo, and we've been doing some work there as well.
Excellent. Okay.
Is that the Facebook one or a different one?
Yeah, it's the Facebook one.
Okay.
Any further questions for Amaury about those two items?
I'm just curious how the collaboration with MoveFast has been going. Like, do you talk with them on a daily basis? Are they like super stoked about the stuff you're doing, or is it kind of just, we'll just review the patches as they come sort of thing?
No, they're quite helpful. Obviously, it's not their number one. Like, especially lately, they've been actually deploying QUIC in production at Facebook. So they have been a bit distracted over the past few weeks, but in general, they are very supportive of the effort.
I guess I have a question. Like, I look at that repo. By the way, I posted the link to it in the chat if anyone's interested. So I noticed that you like separated out all the code for the crypto stuff.
Yeah.
Like, is there still a bunch more to do in addition to that?
Well, as far as they are concerned, not that much. I mean, it's done for all the common part of the code and the client-specific part of the code. No, the server side remains to be done.
Okay.
But then the rest doesn't really depend on them. We can.
So that's
once.
So the rest. So like,
yeah,
so the new crypto basically.
Yeah, so QUIC by default use TLS, but TLS doesn't really work for us very well because there is the whole certificate business that don't really make any sense in a peer-to-peer network, and there's like a ton of Basilian ciphers, but we already rely on the security of SHA-256 and big SecP, SecP 256K1, and so adding like all the more crap that exists in OpenSSL is just adding, adding attack vectors basically. And so So if you were to use TLS, it would be basically using TLS in a specific way where you have to disable almost everything, and someone is gonna forget to disable one specific stuff, and suddenly you have an attack vector that is enabled. And so the road we've taken instead is to not use TLS, but instead use something that is based on noise. So I don't know if people are familiar with noise, but this is a framework to create encryption protocol. So this is not an encryption protocol. It's essentially like a meta encryption protocol where you plug in the primitives you're interested in, and it gives you an actual encryption protocol. So we want to use noise and plug in SecP 256K1 as an elliptic curve, and plug in SHA-256 and maybe AES for the encryption. And so a few stuff that we already rely on, and noise can generate out of that a nice encryption protocol. So this is the plan.
That sounds good. I guess my other question is in terms of managing the code. So like Facebook has this repository. Is the plan to basically just pull, like once it reaches what you need, to just pull it all into the ABC repo and then like port over patches over time? Or how do you, because you probably don't want an external dependency, I guess. I don't know how.
I don't know. We have various external dependencies. If we don't modify that code too much, then it's fine. It depends how stable the API is going to be.
Okay.
I think right now the library is quite new, and QUIC in general is very much in flight right now, because they are nailing all the details of the spec. So there is already an IETF spec, but as you know, like people work on implementation, they work on the spec, and as that happens, people realize that, oh, there is like this obscure corner of the spec that is actually not very well specified. And Facebook is doing it one way, but Cloudflare is doing it another way, for instance. And so there are like small tweaks here and there to the spec that still happen.
So you'd want to track the Facebook or whatever, like you'd want to track that repository, I guess, to keep up.
Yeah, at least in the short term. I mean, we still probably want to update it once in a while, right? Because they're gonna fix security patches and stuff like that. But I don't think we want to clone everything.
Yeah.
It's really gonna depend.
Okay.
Like if the API is turned out to be very unstable, then maybe we want to clone everything. We'll see.
So is the noise stuff going to be in that library, or is that going to be like in Bitcoin ABC, you have to provide a noise implementation to satisfy the interface?
It's most likely going to first be in Bitcoin ABC. And then if they are interesting, if they are interested in merging it, we can provide it to them, but we will see about that. In any case, the goal right now is to refactor the library so that TLS can be swapped for something else, and this is almost done. And so once we can swap it, where the code lives can be in any repo already.
So just to clarify, is the plan is just to add the QUIC protocol. It's not to replace the existing protocol, right?
Yes.
Great.
Okay. That's clear.
Maybe long term we want to remove the existing one, but it's you would like to have a very wide adoption of QUIC before you consider doing that. So it's probably going to be several years down the road. Maybe it's going to be never,
Right. Yeah. I'm just stability. That's what I want. So that was my question.
I had another question about Avalanche. I was just curious. Like I noticed there's some Avalanche stuff happening, and I'm just wondering. Like I know Tyler did a bunch of stuff. Like he did a spec, and he had his snow globe implementation. I'm just wondering how that relates to what you're doing, or if it relates at all. Like
it's similar, though I'm focusing on blocks, and the reason I'm doing that is because I want to deploy something in production as soon as possible.
Yeah.
And blocks have much less problem than transactions because there is only one every 10 minutes, right?
Yeah.
So, so you don't have throughput problem. You don't there's just a bunch of problem that you don't have with blocks. So I think it's good to start with that, and it's gonna get us to have some data. We can take like extremely conservative parameters and deploy that and collect data, and then we can use that data to make more informed decision when we want to ramp up with something that require a bit more throughput.
So then it maybe in the future you could extend it to like use it for transactions also, or.
But yeah, that's absolutely the goal. So that we can get zero conf nailed down in probably 2 seconds, something like that.
Yeah, so I talked with Tyler. I don't know if this is valuable or not, but I talked with Tyler, and he said that, so he had an implementation in Go based on BCHD, and then when Ava Labs released their full node a few weeks ago, which is also written in Go, I remember him saying that he's like, oh wow, like some of the ways they implemented things was just much cleaner, just a little bit different. So if anybody wants to pick up the torch and continue Avalanche research, I mean, there's essentially where Tyler left off with the Go implementation of BCHD, and then there's the Ava Labs full node that implements Avalanche. So there's it seems like a Go programmer would be the best person, and there's code laying around to get inspired by.
Any further comments?
Yeah, there's a quick. So it would be great to have a quick summarize of the plan for the next few months in terms of how. When you said that you're going to start with blocks and Avalanche, what's the near goal term apart from deploying and gather data? What do you mean using Avalanche with block? And another subsequent question is there any kind of documentation that people could read about your intention in terms of how to deploy Avalanche in ABC and with what purposes?
Yeah, so the game plan has not changed at all, right? Like, so the idea is to be able to have all the nodes agree on something in a few seconds, and it can be agree on block or agree on transactions. And that means that you can start to enforce various policies and leave them to the aggregate of nodes to make a decision rather than enforce them at the consensus layer. And so we'll see which one we pick first, but generally the idea, like for instance, the block size, you want to, it's difficult to change it in the protocol because, you increase, like it's a hard fork every time you want to increase the block size. But at the same time, you don't want the block size to be like way higher than the actual demand on the network, because then you start opening those vectors. And so, having something that is in the consensus that is absurdly high, and then having policies that are set on various Avalanche nodes to reject blocks that are too big, for instance, is a good idea, I think, right? Because it's not consensus anymore, so it's easy to change, and not everybody has to agree on values on that. So yeah. So I'm not actually sure if like the block size is gonna be the first one. We'll see. Like you gotta get something working before you make all those plans.
So Amaury, I know there's still a lot of for people who like watch this recording later. I know there's still a lot of confusion in the developer community about what the heck does Avalanche have to do with BitcoinCash. So let me give my summary, and then please correct me if I get anything wrong. My understanding of what Avalanche protocol could bring and complement the proof of work that's in place in BitcoinCash is there's really two main aspects. The first is blocks, which I think is what you're working on, where right now we have the 10 block checkpoint, which protects us from malicious miners.
Yeah.
And doing the Avalanche would be more of a dynamic, rather than having a hard coded 10-point block, it would be more of a dynamic checkpoint that could be voted on by miners. Is that a good summary?
Yeah, it may not be by miners. I think, yeah, it's going to be by whoever participates in Avalanche. It's probably not going to be limited to miner, even though miner definitively can participate. The problem is that if you limit that to miners only, then what happens is that you can have a group of miner that can decide to vote no to any new miner entering the market, right? And so you effectively have created a permission system.
Okay, right.
Yeah. So you don't want to limit the participant set to only miners, but definitively, you know, like miner would be expected to participate. Like they have an incentive to do so, right? Because they want their block to be accepted by the network. They want to have the best information about what other people are making as the decision.
Right. So yeah, so that's my understanding of what Avalanche can do in terms of helping build on top of proof of work in terms of the checkpoint, and then the other area,
so the 10, you're right about the 10 block finalization stuff. That's one of the stuff we are looking at, you know, removing and replacing it by Avalanche. That would be a much better solution.
Okay, and then the part that Tyler was kind of focusing on, the transactions, would provide instant confirmation, essentially, like prevent double spends. And is having a brain fart on the word pre-consensus. It would essentially be pre-consensus.
But you cannot, like, so yeah, people have been separating the two a lot, but they're actually not that separated, right? Because if well, you can do it on block only, but you cannot really do it on transactions only, because a block can conflict with a transaction. Right? You can have a transaction that say you sent me money, and you can have someone that mines a block that send where you have another transaction that say you send money to Jason, for instance, right? And so now you have a transaction and a block that are incompatible. So you need to have Avalanche to resolve that. That's another reason why I want to start with blocks, because
that makes sense. Just much more approachable. Yeah. I can see that.
Yeah, the term I've been using to kind of help people understand Avalanche is that Avalanche helps us with finalization. So whether it's transactions or blocks or policy, like it's just a way of being able to finalize things very quickly without having to make protocol changes. I hope this will kind of like make people understand it a little better, rather than, you know, focusing on one specific aspect of what Avalanche could or could not be used for.
Yeah, exactly. I think there's just a lot of general confusion. So just sort of breaking down a high level, sort of how Avalanche complements proof of work. There's just a lot of unreasoned like fear and FUD around it. But
well, I think a lot of it comes from a very bad habit that the crypto space have taken for a while, where people have been talking about proof of work consensus and proof of stake consensus and all of that. And as it turns out, you have consensus algorithm, and then you have proof of work or proof of stake or whatever, proof of space. There have been like many of them that ensure that you can limit the participant set, right? And it's important because if you create a consensus algorithm, then you have, you know, a certain number of parties that need to agree on something. And if you don't have any way to vet those parties, right? So the traditional way to do it was to do a permission system, where you have a set of parties that are authorized to get involved in the decision making, and nobody else has the right to do so. And that works, but that's not ideal. That's not what we want, right? So we want to have a permission-less less system where people can join and leave and rejoin, and also people can join and leave, right? So you need to have a proof of something to enable that, because otherwise you, Chris, can spin, like 1 million nodes, and it's going to be like Chris 1 and Chris 2 and Chris, up to Chris 1 million. And you can pretend that you just 1 million participant, but it's not yourself, and you effectively control the network. And so you need a proof of something. You need a proof of some resources that is scarce, to simply like vet a set of participants to make a decision. And you have different algorithms that allow to do that. So using a blockchain and measuring which tip of the chain has the most weight, measured by whatever work or stake or whatever, is one way to do that. But it's a very slow and inefficient way.
Right.
So you come to conclusion like very slowly, and finalization is very slow. On the other hand, it's very good to verify, right? Because you can just download the header. Like if you are an SPV, you can track the chain header. You don't need to validate everything down the road, as long as you trust that, like most participants are gonna follow the right chain. And so the blockchain is useful in that way. It's a way to come to an agreement, but it's not a very efficient way to do that. But it's a very good way to communicate the agreement to all the participants in the network. And so the idea is to use something that is much faster to come to the agreement in the first place. Like this transaction is in, this transaction is not gonna go in, this kind of stuff. And this is much slower. This is much faster than the blockchain, but obviously this is not something that you can communicate very easily to people that join and leave, and so you can say, okay, this transaction is gonna go in and it's gonna get mined by a miner eventually. It doesn't even need to get mined in the next block, right? But as long as it's not mined, that it's not very easy for all participants to know that this transaction is validated unless you were connected at that time, and so the consensus on that transaction specifically happened. But yeah, you get something instant in terms of decision, and you get something that is eventually very easy for everybody to fetch and verify that the decision has been made. So it's if we were to take like an analogy that people maybe used in the real world, like if you buy something very expensive like a house, usually you're gonna go through a notary, and the notary is gonna verify a bunch of crap, and it's gonna take like amounts and whatnot, and get the authorization, and essentially like and then register the decision that you bought house and you are now the new owner of the house, and the previous owner was someone else. But what happened in practice is that people just don't go through the notary right away. Right. And this is what we're doing right now in BCH. Like we are all processing everything through the notary. But what happened in practice is that people who want to sell the house and people who want to buy the house, they meet and they come to some kind of agreement, and they sign they sign some contract between themselves to say, okay, like no, we are going to the notary and finalize that decision, but essentially we already have a contract between the two of us, and unless there is something wacky that happened with the notary, the house is effectively bought. And so what we are doing is something similar, right? Like you want to have a lightweight process that is very fast for for people to come to agreement, and for transaction to go through like very quickly and very smoothly. And then you want to have some kind of permanent record of the decision that have been made, so that a third party can check, that everything is all right, except, maybe what happened during. So if we talk about notary, essentially the decision that are kind of blurry are going to be the decision that happened, during the last months or so. But everything before that is very clear. You can track all the history of, who owned what for a very long time. and very reliably, right? Because all the notary, they talk to each other and they make sure that, you know, you're not trying to sell the house through one notary while you sell the house through another notary. So all of that, you know, takes a lot of time, and this is why this process is so slow. But it's also why it's reliable and easy to check and all of that. So that process is effectively the blockchain. And right now we use only that, but we want to have like a second, more dynamic layer, even though it's not as easy to check ex post facto.
I mean, in a way, like you say, we only use that, but in a way, like the other way I'd frame what Chris is asking is, right now we have the first seen rule on the network, which is basically our fast way of determining what's going on in real time, but it's not a good, so like you should basically compare Avalanche to the first seen network.
Yes,
rule,
yes,
don't compare it to proof of work. So it's basically replacing, so like right now we have the first seen rule, which isn't a great consensus algorithm. But
the problem is that it's not a consensus algorithm at all, right?
Yeah,
so everybody run an algorithm,
but we're basically
and nothing forces them to do it, right? In addition, right? So most people run that algorithm, and you hope that they're gonna come to the same conclusion after running it. And most of the time they do, but they actually don't always do, because your input is subjective to begin with, right?
I mean, we're basically trying to use it as a consensus rule, like for zero conf and all that. So that's why I'm just saying, like, you should think of Avalanche as replacing that. And like proof of work is kind of a separate thing. Yeah, like it's like you have a meeting of people talking, that's what Avalanche is, and then like writing down the minutes of the meeting or whatever is the blockchain or something like that.
Yeah, this is good. This is good. I mean, I'm with you guys 100%, but I think like people who are wondering, we can send them to the recording of this video and they can get a deeper understanding of it.
Could you give us an update, Chris Pacia, on BCHD for the upgrade on May 15th?
Yeah, I still have some more work to do. It's mainly around writing tests for it, which hopefully I can finish this weekend. I guess a question I do have regarding the SIG checks. Do we have, this maybe for you guys in ABC, is there like any kind of like test blocks or mock blocks that you guys have that you can just run it through, count up the SIG checks, or is that any other kind of test vectors for that? Because I didn't see when I took a look through, but could have missed it.
Yes, there are tests definitively for that in the code base, but I think they are unit tests. So
yeah, that's what I was saying.
Yeah, so you kind of have to port them, because it's not like they're gonna generate a block in a test vector that you can reuse. Maybe we should consider doing test vector for those.
Okay.
We don't have JSON text vector like we have for opcodes and stuff like that for that. Maybe that's something we should be looking at.
Yeah. All right, that was my only question. It's mostly just the test that I need to finish up.
All right, thank you, Chris. Bitcoin Verde, Josh Green, do you want to give us an update on your work with regard to your node?
Sure. So we are currently working on basically that miner version of Bitcoin Verde, which is a really large overtaking for us, which is really awesome, but it's really sped up the initial block download for our node. But because of that, we haven't really worked too much on the upgrade for the 15th, on top of the apocalypse and also what I call the baby apocalypse, which is my newborn.
Yeah. Congratulations.
And yeah, thanks. So we will be compatible on the 15th, but we're not going to be implementing everything right away. By that, I mean basically like Bitcoin Verde doesn't count SIGOPS currently. So we're not going to count SIGOPS for the 15th. So we're still compatible. We're just going to implement OP reverse bytes. And then as soon as we're done with the actual miner overhaul, we'll implement the SIGOPS and then continue on with our roadmap for being a mining compatible node. So we'll be compatible. We have a lot to do still. A lot of it has to do with just different priorities in the world. So we're getting there.
Thanks. Any questions for Josh Green on his work? Any further congratulations on the newborn?
Hey, Josh, I had a question for you on Bitcoin Verde. I know it's got some indexing capabilities. I wanted to confirm, does it index UTXOs and address balances?
Yeah, so that, again, it's going to be dependent upon which version you're talking about. The original, like the current release version, or even the development branch version, indexes just about everything, which is why it takes so long for it to sync. And yeah, it indexes SLP validity, it indexes the UTXO set, I mean, like literally every component of the blockchain is indexed. Like everything except for the literal usage of opcodes. So like you still have to like inflate the scripts to count how many times the opcodes were used. Which, I mean, yeah, we could do that, but that's the opposite direction of where we're going now. The new version that we've been working on still indexes transactions and still indexes, you know, even addresses, but it's now optional. So basically, if you're a miner, you can still be running an index node while only having about like 350 gigs of disk space instead of like the 750 that Bitcoin Verde currently uses.
Okay, yeah, that was my next question. Like, if everything's fully indexed, roughly, what's the footprint and what's the sync time?
Yeah, the sync time depends on your hardware, just like everybody else's, but even more so than most. With the old version, with the NVMe, I think it takes like a week to sync, assuming nothing goes like bad. And then with the new version, I think I got it going to like 19 hours right now. It is a full sync. And then the like indexing of the address and stuff catches up. It's a separate process. But like I said, the new footprint's about it's so much smaller. Basically, just the way that we store data is a lot more smart. But you lose the ability to like write arbitrary queries against the database, like versus like the old version. Like you can join all sorts of stupid stuff, and it's cool, but it's just not performant from a from a scalability perspective. But we still are planning on supporting indexing SLP. We still like part of our validation process requires that we index transactions, so we know exactly which transactions in which block. And then we also know how many outputs are in each block. We also know which transactions are a part of. Which addresses are in which transactions. That part's optional now, but yeah, so that's all indexed, and it should basically get you what you need. If you're looking at using it for something and you want some use cases, definitely just ask us and communicate what you like need indexed. And if it's not already inherently available, we'll try to make sure it's available as a configuration option going forward.
Awesome. Yeah. I'm constantly trying to spread more awareness of what is an indexer, why is it important, how does it work, what's the footprint, what are the different implementations. So on the topic of indexers, I've been playing with Fulcrum, which is Kalen Caliano's implementation of Electrum X, and it's the smallest, fastest indexer I've ever seen. Testnet synced in like 24 hours, and the footprint's only like 8 gigabytes. I don't know. That's voodoo magic to me. I don't know what he's leaving out or what. It'd be great to get him in meeting here, David, and I'd love to see a meeting of the minds of full node people and indexers, and because those are really the two critical pieces of information like a wallet app needs to have in order to just do basic functionality on BitcoinCash network. But thank you, Josh.
One thing I've seen on Index is there's like a high demand. Actually, one of the most in-demand queries to make is give it the address and get back the UTXOs for that address. So like an address UTXO index. And so the way we do this, and like we don't have an index that maps addresses to UTXOs and BCHD. So what I do is you give it the address, I load all the transactions for that address, and then parse through them to calculate the UTXOs. And that works for normal addresses, but it works terribly for addresses that have like 1 million transactions. And so it's possible like we might do like an address UTXO index at some point, but I would also say, depending on the application, I don't think people kind of realize that you can calculate your UTXOs client side. So like one thing you could do is like download all your transactions and then just like mark the height at which you've seen up to. And then like next time you want to download your transactions again, only download it from that height, you know, to the tip. So you're not like slamming the server that way. And then you have all your transactions locally. And then when you have all your transactions locally, you just, you know, add in the inputs and then remove add the outputs, remove the inputs, and that's your UTXOs. So if your app has the ability to do that, I think that's a better way of doing it client side rather than relying on a server side endpoint. But I guess it depends on what the app is doing.
Yeah, I know that's how James Kramer implemented it in SLPDB. I don't know if BitDB, which is based on BitDB, so I don't know if BitDB does that, if it has a UTXO set, but I know that that's exactly how he approached it in SLPDB for a while there. And then so at my experience creating applications, the two most fundamental pieces of information that's not like directly available by a full node traditionally is the UTXO set and address balances, and those are like critical. And like so I've played with BCHD, and I actually just implemented it in BCH API, so I can call BCHD full node and query the UTXO database, and that's been great. And so the only thing they're missing is address balances, which I still need an indexer for. Yeah, so it's just you know, if you guys are interested in sort of the needs of application developers, those are like the two most fundamental things. And one of the things that I'm constantly trying to educate the developers I work with is what is an indexer, and this address balance and UTXO for an address. Those are like just they're the constant problem that we're always trying to solve, and there's so much you know, there's a lot of full node implementations and there's a lot of indexer implementations. So any application developer who comes into the space and wants to build a BitcoinCash app, this is like the journey they have to go on. It's like, okay, like what's an indexer? Why do I need it? You know, essentially, how do I build my app?
Yeah, the in OpenBazaar, I have a wallet. I actually have a new version that I've worked on that's not released, but the way this new version, it doesn't use a get UTXOs endpoint. It calculates its UTXOs client side. It just only hits the transaction endpoint, basically.
Very cool. Yeah, that sounds much more efficient.
Yeah.
Hey guys, thank you for all that great information. I'm just going to bring you up to date. Unfortunately, Andrea Suisani from Bitcoin Unlimited had to leave, but he did pass on this message about the upgrade coming up. He said BU is ready. He wanted to ask when the next testnet activation is going to happen. Just the discussion is going to take place in the work group, I believe, but could you give us a little bit of an idea of where things are at with what's going on with the testnet right now?
I guess I can talk about that. Yeah, I haven't done much in the last few weeks on testnet, but yeah, if he wants to do another activation, I could organize one, I guess, for next week sometime. Yeah, I'll just talk to him offline about that, and yeah, we could do another activation next week or something.
Okay, that's good. Just
the testnet there, it's running. It's just on the normal testnet right now. It's not activated at the moment, so we can run another activation test.
Okay, that's good to know. I guess that sort of leads into the next item on the agenda, which is to get a little bit of an update on the BitcoinCash specification work being led by Josh Green.
Yeah, so we just talked with BU, I think last week or so. So they approved the, I think it's like a lot, like 3 times as much budget as they did last time for the specification, which is awesome. So we applied to continue our work sponsored through them, and they've tentatively agreed to use us. I think the only reason why we're not literally working on it right now is I think Andrew Stone is like sick, so he's I don't know what he's sick with, but he's just recovering. And then I think as soon as he feels better, we're gonna actually start picking that up again. So that's, from my perspective, great news, and that we'll keep working on it. I know that people have been contributing to Bitcoin Unlimited's repo. I'm trying to remember what the location of it is. We've talked about the location for it before, but people are making like pull requests, and it's starting to actually get some community contributions, which is a huge step for the specification, because it's not really sustainable just to have one organization constantly sponsoring the development of it. We're trying to really migrate it to it being a useful resource so that people can try to keep it up to date. So we're starting to see the traction there, and that's great. And as soon as we actually start working on like full-time work on the specification again, we'll definitely make an announcement about it. But that's in the works. It's coming. Super appreciative of BU for taking that time and effort, and also the finances to actually enable us to do that. So it's coming. It's coming. We're just waiting for things to kind of settle out, and then we'll keep going. So
Great. Thank you, Josh. It's good to see that work going ahead. Anyone have any questions or comments to Josh on the specification work?
Great work. Badly needed. Thank you.
Okay, another thumbs up from Jason B. Cox as well. Okay, that's great. Thank you, Josh. Moving on to the next item on the agenda. If I can find it here, I seem to have. Okay, the elephants in the room, don't mind me saying that. Jason Dreyzehner, I'm going to ask this of both you and Chris Troutner. If you could bring us up to date on your projects, that would be great. So we'll start with Jason, if he's there.
Yeah, I don't know if I have too much to share right away. Well, I can go ahead and I have a pull request on the Bitcoin TS repo, which is just about to complete the compiler for BitAuth templating language. So what I've been working on is a way to generalize a wallet where you can write locking and unlocking scripts as templates with this sort of very, very simple templating language. And the compiler figures out dependencies it needs from each entity. You have the concept of entities. You have multiple entities that are part of an authentication template. And you can create a fully generalized wallet from these JSON descriptions of a wallet. And it can compile out the proper locking and unlocking script to create the addresses and to spend from outputs that are paying to those addresses. So shortly, hopefully in the next month or two, I'm hoping to release a fully generalized CLI wallet where you can import these templates, which would mean that you no longer need to, if you want to implement a new type of wallet that's doing some strange unlocking script and locking script, you can actually just write it in this JSON format, and the compiler can figure out how to create addresses and spend funds from those addresses without you having to write any code to do the signing or write any code to serialize the script properly. So it's quite an ambitious project, but I'm just about finished there. So probably in the next month or so, I'll have more to share there.
That's great, Jason. Any questions for Jason on his work?
Man, that's really cool. Have you reached out to Roscoe Callis at all?
Yeah.
Good. Just
and Tobias, we've talked quite a bit on Telegram, but yeah, I'm actually hoping that the thing that I'm focusing on a little bit more with this compiler than what the other guys are working on with the higher level languages for the scripting is sort of where the language actually meets real implementations. So I have the concept of entities and variables and expectations for which entities provide provide information to which other entities. So like on net, I've actually been working on maybe it's much lower level than the cache script stuff or Spedden. But actually, I'm hoping that we can get cache script and Spedden to compile to BitAuth templates because they're actually very easy to implement on a wallet side. You can implement BitAuth template support in a wallet and get this fully generalized wallet support with relatively little code. I think the compiler is less than 1,000 lines altogether. It allows you to write a fully generalized wallet. So it'd be perfectly possible to write scripts in cache script and then compile them to BitAuth templates and import them into the CLI tool that I'm making, and you'd be able to just use them as a wallet with no further development required.
Yeah, it sounds like the way that you're splitting up the concerns by sort of abstracting inputs and outputs and using a JSON format. I know cache script compiles into a JSON format too. So it sounds like everything's aligned there for compatibility.
Yeah, totally. And I haven't talked to Roscoe this month about it, but he is actually probably the next person I need to talk to about it. As soon as I get the as soon as I get this pull request out, that's probably my next step. But yeah, there are a few places where Spedden and cache script, of course, can compile all the way down to bytecode, all the way down to unlocking scripts and locking scripts, as you can conceivably create transactions with them. But there are places where it starts to get a little bit messy because those languages at least don't yet include the concept of like security domains of some sort, where you have certain entities know certain information and other entities know other information, and this entity does not have access to that entity's private key. And so if you are going to make decisions about that, your language needs to incorporate the ability to describe who knows what. And right now, neither of those do. So it'd be awesome actually if we could just compile them to the BitAuth template format. And then the transaction creation flow is done, and they can focus on being higher level languages.
Very cool. Very cool.
That's great. Any further questions for Jason? Moving on then to Chris Troutner. Do you want to give us a little bit of an update on those projects that you're working on that as they relate to the overall ecosystem for BitcoinCash?
Yeah. I'm just going to share my screen real quick, if that's all right.
Cool.
I am expanding on top of the, let's see. You guys still see my screen?
Yep, it's good.
Okay. I'm expanding on top of my work that I was doing at bitcoin.com. I've launched fullstack.cash, which is sort of a BitcoinCash blockchain as a service. And it's based on this framework here, this block diagram, which is a framework for how you go from a phone app or a web app to the BitcoinCash blockchain and sort of the different layers of software. And so, like I said, this is an extension of the work that I was doing at developer.bitcoin.com and rest.bitcoin.com. This is a very similar API. It's a fork of Bitbox and a fork of rest.bitcoin.com. And I've got a handful of developers. I've created this permissionless software foundation, and it uses an SLP token. Please take note of the big yellow sign saying that this is not an investment, because really it's just an experiment. But it's an SLP token and an app that you can send. And this app just exchanges BitcoinCash for SLP tokens. And I've got a whole business plan down here if people want to like really dig into it and find out what this is. But I just wanted to point out fullstack.cash and psfoundation.cash if people want more information. Right. But I'm working with Daniel Umberto in Venezuela and Andrea Cabrera in Brazil, who was behind mint.bitcoin.com and Pitico Cash. So he's building a slimmed down web wallet that's going to work with fullstack.cash, and he's using my IPFS template that allows you to build a web app and then syndicate it over the ClearWeb, Tor, and IPFS. And so it's cool. What's cool about it is it's going to be a web wallet that is essentially uncensorable. Anyone in the world will be able to access it. The bottleneck is going to be like the back end that it talks to, yeah, I can talk to that more in a minute. I'm also working on a way to build sort of a distributed back end as well. And so I'm pretty excited about this web wallet that he's created, and it's based on that stack of software that I have at fullstack.cash. And so these guys are working with me, and we're tracking our time with these PSF tokens. And if we do our jobs right, the subscriptions from fullstack.cash will go to burn the tokens and cause the tokens to increase in value. So that's kind of the idea. And also, so the way I'm going to do it is 5% of of each subscription will go to the full node implementation that we're running, which right now is ABC, and 5% will go to the Simple Ledger Foundation, because we leverage their work heavily with SLPDB, and then the other 90% will go to burn PSF tokens. And so it's all an experiment, not an investment, but that's what I'm working on. It's great to have the handful of guys to work with. I'm really excited about sort of our trajectory of where we're moving.
Yeah, I remember an experimental project that started in 2009 that's still going today. So I love experiments. That's how science gets proven out. So thank you very much for that, Chris. Any questions for Chris on his work? No? Anyone else have anything that they want to add to this meeting before we wrap up? No? Well, again, I'd like to thank, oh, Jason, did you want to say something?
I was going to ask, has anybody, I messaged on the group earlier, just curious, is anybody working on stealth address stuff, the reusable payment codes? Where does that stand right now?
Man, I'm really glad you brought that up, because that was another thing I'd love to just query this brain trust. So I've been looking into this because Puck's just released a BIP47 implementation in Crescent Cash, and then me and Colin Instead were sending money back and forth and playing with it. And it's, boy, talk about voodoo magic. BIP47 is kind of crazy. But my understanding is, like, if there's 3 different obfuscation protocols. There's BIP47, there's imaginary usernames paycodes, which is partially implemented in Electron Cash, and BIP47's in Puck's Crescent Cash app. And then there's Chris Pacia's work on stealth addresses, which that seems to be the most approachable to me, mostly because Gabriel Cardona took a stab at it, and he's got some code that I can try and pick up that's in JavaScript. So this is one of those are all like solutions to the same problem. And I've been trying to read up on it. Andrea Antonopoulos has a pretty good video where he goes into BIP47 and the Diffie-Hellman on-the-fly encryption thing that happens there. And so I'm trying to investigate this, because this is obviously a feature I'd like to offer through fullstack.cash, or have Andre work into his web wallet as a plugin. But so that's my knowledge of where it stands, and feel free, anybody, to sort of pick up on that thought train and even poke at it.
Yeah, so the work on that is actually like not quite new. There are stuff like BIP47 that have been around for quite a while. The main problem with BIP47 is a scalability problem, because essentially you end up with one HD wallet per pair of participants. And so the load that you create on the server side to query all those HD wallets becomes stupidly big very quickly. Like, essentially it scales with the square of your users. And so, assuming that the connection between users are somewhat homogeneous, but in practice, it works close enough for small network. It's more like n log n for large one. But in any case, you don't have a very good scalability characteristics, but you get very good privacy out of that. So that's bit 47. Then you have stealth address, and you have various implementation of that with various details that change, but the basic ID is the same. And you also have a scalability problem with those because you end up having to grind something in the transaction, be it like, is there the signature or some up return, like the initial implementation of that used an up return, but now people are getting smarter where, they grind like a signature or something like that. And if the signature has the right prefix, then you know that it's possibly one of your transactions, then you run defilement on that. But that means that first, your anonymity set is reduced, right? Because you need to give to some servers your prefix so that you get the subset of transactions that are possibly for you. So already, like, the longer your prefix is and the smaller your anonymity set is, up to the point where your anonymity set can be, quite small, and therefore you don't get any privacy out of that. But on the other hand, if your anonymity set, if you choose a very short prefix and your anonymity set is very big, then you end up having to process a stupidly large amount of transactions, right? Because then the servers, like, if you choose like no prefix at all, then you have to process every single transaction and do a defilement for every single one of them, which is not something you want to be doing on the client side either. So all those solutions, they have some kind of like scalability, privacy trade-off that come with them. And so then you have finally, I think, a third approach that it's kind of disappointing that Shay is not here because he's been working on that, which I think is the one that makes the most sense, where, so right now, the way we do transaction kind of doesn't make sense, in my opinion, because what we do is that, so if I want to send a payment to you, Chris, what I'm doing is that I'm making my transaction. So first, like, you send me an address or something, right? And then I make a transaction that sends money to that address. And I don't give that transaction to you, right? I throw it in a giant pile of transaction with everybody else's transaction in there, right? And somehow there is some other service somewhere on the internet that managed to gather as much of this pile as possible and muddle through all of it and be like, oh, that looked like something that is for Chris, right? So let me send that transaction to Chris. And that process is evidently not scalable, and it's not very reliable either. It's kind of weird, right? So the way you'd want to do that is like all financial system work with some variation of that. Is like, I make the transaction, I send it to you, and you broadcast this to the network. And if the network say yes, then you say yes to me, and this is the end of it. And if the network say no, you refuse my payment, and that's the end of it as well. And if you use that model for payment instead, then you can do much better stuff with anything that is stealth, right? Because you don't have this scalability problem anymore, where you have to muddle through a giant pile of crap to try to find the transaction that are possibly yours, right? But it's like with the old model, it's fundamentally unsolvable, right? Because the more transaction I have that are possibly yours, and the bigger your anonymity set, but then, the more crap you have to muddle through. Or you give me something very precise, you're like, okay, here is a very precise criteria that tells which transactions are mine. But in that case, you voided your privacy, right? So,
yeah, I can see that.
Yeah, so I think the third one is the right approach. The good news is that you can use test address to do that as well, right? But instead of using a prefix or whatnot, I'm just like giving you the transaction. I'm like, okay, this is your transaction. You don't need to muddle through everything with a prefix. I can hand it over to you. And this is compatible with bit 47, I think.
Yeah.
Bit 47 already send the transaction directly to the recipient. And you can do stuff that, do that.
And so this third option, this is what Shay's been working on?
Yeah.
Okay. Is there, like, has he named, like, is there, I guess I could just ask him about it. I'm just wondering if there's anything.
Yeah, so
code to
he has a
look at.
prototype. So what is done, what is done is that he's integrated that into some chat application that is also a wallet.
Oh, okay.
And
Yeah, no.
and so yeah, so you have like an interface that kind of look like Telegram or something like that, where you can chat with people, and you can pay to reach people that you don't know, you know, to grab their attention. So that's a way to do spam filtering. But you can also like pay, you can send money to your contact, right? And it's using a variation of stealth address, and all of that works by sending directly. Well, there is a server in between because you know. You have to, but the server does nothing then, you know, except forwarding messages back and forth and verifying that messages are well formed.
Great.
Cool. I just put a link in the chat. I think it's called Cash Web Stamp is Shay's project. I have not had a chance to play with it, but this is you're probably like the third person in 2 days to tell me that I need to check it out.
Yeah, I think it's an interesting project. Yeah.
We'll definitely get some more information about Stamp. I've been having the opportunity to do a little beta testing with it as well. So yes, any other further stuff that you want to mention at this point, Chris?
No.
Okay.
Amaury, just to clarify, this is not the BCH reusable address proposal from Imaginary Username. It's using Bit47.
Right. No, that was Shay's project. I do have a link to Imaginary.
Yeah.
Shay's project doesn't use like exactly imaginary username stuff, but it's a similar ID.
Cool.
Like, you know, like the implementation details are different, but the general ID is the same. Like you use some kind of diffie-Hellman to, you know, generate a shared secret between two parties. And then you use that to you know, generate addresses to send the money to.
Cool.
Because those addresses are generated, you know, like based on secret between two parties, only those two parties knows about those addresses. The main difference between imaginary username proposal and that is that imaginary username proposal work with a prefix, right? So you send the transaction to the big pile of transaction.
Okay, so the stamp thing is not doing the signature grinding to get the...
No, the stamps have directly sent the transaction to the recipient, right? And the recipient can check if this is a valid transaction or not and accept the payment based on that.
Okay, cool. And I finally read through the Imaginary Username proposal like a couple days ago, and it looks like it has both mechanisms. But okay, so it sounds like we don't have a definitive winner yet on the stealth address thing.
No.
Still
no.
Cool. All right. Well, I probably won't bother adding anything to Bitcoin TS until there's a little bit more review, because I'm not really the right person to do the review. Cool. Thank you.
Great. Thank you, Jason, and thank you both Chris and Amaury for providing the details on those items. I think we're going to wrap up. We've been going for a little over an hour now, and I'm going to just mention that we had a halving event yesterday that took about 6.5 hours. I'll also be in the process of editing that down into manageable chunks. If you have 6.5 hours of free time and you want to watch it, it's still up on YouTube as it is, but we're going to break it down. We had some great participation with some good people. Amaury was there with Naomi Brockwell and some of the other key players. Chris Pacia was there. So that was towards the end. We had a lot of exciting projects and builders in the BitcoinCash community. We're also looking forward to doing more of those kind of get-togethers for people now that we're into a social distancing. Of course, we're all used to social distancing because we've been doing this for some time, but the rest of the world is having to adjust. So we're going to look forward to editing this out and moving on to the next phase in the development of BitcoinCash. So I'd like to thank you all for being here today and look forward to next time.
Bye-bye.
Thanks.
Thank you guys. It's really good seeing you.
Thanks, guys.